Annoying. Alright, today we are going to talk about how to find missing angles in right triangles using trigonometry. What we've done is find missing sides using trig. Today we're going to find missing angles. To do that, we first need to, again, know how to use the calculator, put it in the right mode. So, we're going to practice real quick inputting this information into the calculator. So if you don't have a calculator, make sure you grab a calculator here before we get started.
Make sure it's in degree mode.
And make sure it's in degree mode. That's always the first thing you should check. So press mode up at the top.
Go down to degree mode.
And the third option down, degree should be highlighted. Okay. So now, what we're going to do, we're going to look at something like this. Where we've got sine of theta equals 15 over 22. And we're gonna, when we set up our equations down here, we're going to end up with things that look like this. Okay, this looks a little different than what we have been working with. Okay, now what I'm going to try to solve for is theta, the angle. Okay, I'm not trying to solve for a side that's over here anymore.
I think I'm getting the point.
Okay.
Sin is opposite over hypotenuse. Do you have to redraw a triangle then? Or is there like a faster way to do it?
Well, we're not going to have to redraw the triangle when we start here. Okay, on the back, we will have to draw our own triangle sometimes. Okay, but here, if I already have this information, what I'm trying to do is solve for theta. Right now, theta is trapped inside the sine function. Right? I need to do something to both sides of this equation to get theta by itself. You did do this in geometry. Okay, that was a while ago. Right? So you probably don't remember how to get theta outside of the sine function, how to get theta by itself. What we're trying to do is find something that undoes sine. Not quite. I mean, you're on the right track, though, right? We want some kind of inverse operation, right? Like, if this were being multiplied, we would want to divide. If it were being added, we would want to subtract. What's that? Yeah, okay. It's actually called inverse sine. So what I'm going to do is take the inverse sine of both sides. That's sine with a -1. You can see that on your calculator. So I'm also going to do that to this side of the equation. I know this is backwards. We don't write the sine inverse after that. So what happens here? The inverse sine of sine cancels out, and we just end up with theta equals the inverse sine of 15 over 22. Okay? When I take the inverse sine of both sides of the equation, this sine and inverse sine cancel out, and that's how I get theta by itself. Right? So now we want to practice inputting this into the calculator. If you look on your calculator, right above the sine, cosine, and tangent buttons are that sign with a little -1, cosine with a little -1. Those are inverse sine, inverse cosine, and inverse tangent. To get those, you press the second button and then sine. Right? So try that right now. Put in inverse sine of 15 over 22 into your calculator.
Theta equals 42.98.
42.98?
Yeah.
Okay. Now, 99. 99 if we round.
How you do it? You do sine.
Press the second button. And then press sine.
Boy, you said that so many times.
Okay. So, now what we just solved for was an angle. So, our units are going to be degrees. Right? This would be 42.99 degrees. Right? Same idea is going to happen for numbers 2 and 3 here. Okay, to get theta by itself, I want to take the inverse cosine of both sides here. Okay, so, taking the inverse cosine of this side and the inverse cosine of this side. When I do that, cosine and inverse cosine cancel out, and we just get theta equals the inverse cosine of the square root of 13 over 17. So what do we get when we put that in the calculator?
What's the root there?
29.01. 29.02 degrees. Is that what everybody else got?
Yeah.
Double check these.
I got 20.20.
Seriously. So fast.
Oh wait, never mind. Next one. Don't listen at it.
Yeah, I got 77
Looks like
points.
it's a 10.
Yeah.
How do you?
Maria, you sure you put that in there?
No, no.
Make sure.
You got that?
Wait, you gotta take the 11 out of the square root and the division side.
Alright, let's see here.
Well, you gotta do the 2 to the square root of 5. Oh, is that mine? Okay, yeah. See how it's 13?
Mikey, we're on.
Under the square root?
Yeah, I
You
got
had the 17 division.
I got 77.
Yeah, never mind. I know what it is.
Yeah.
Because you can't square root the entire thing.
No, I know.
77.76 degrees.
Yeah.
Back to how?
I already figured it out.
I'm saying it for myself.
The next one's 22.12.
So here, if we take the inverse tangent of both sides and get theta equals inverse tangent of 2 times the square root of 5 over 11, we get, what was it?
22.12.
42.12 degrees. Is that what everybody else got? Alright.
No, but it's okay.
So
Well, I think it's because I kept putting.
Yeah, you got it
I
useful
put the square
and
root
push
under
it up.
oh yeah.
Yeah,
So
I
you
don't-
have to hit the arrow button over. Alright, so do we feel okay with inputting this into the calculator? Alright. So let's actually look at some triangles now and solve for some missing angles. So when finding a missing angles, we have to know 2 sides of the triangles, right? At least 2 sides.
You didn't know in the first line.
Oh, we didn't, did we?
No.
So then take the inverse of both sides.
I guess I could guess that one.
Alright, so we need at least 2 sides of the triangle. Okay, we could know 3. Okay, but we only really need 2 sides of the triangle in order to find the missing angle. To find the missing angle then, we're going to set up a trig ratio just like we've been doing. But now we're going to take the inverse of both sides, like what we just practiced here. Okay, so let's see what that looks like in practice. So let me scroll down here.
I wish it's Bible.
Alright, so in number 1 here, we are going to start the exact same way that we have. Okay, the first thing we're going to do is label the sides of the triangle. So with respect to theta, is 4 opposite, adjacent, or hypotenuse? Opposite. And 10? Hypotenuse.
Let's see.
So if I'm dealing with opposite and hypotenuse, that's sine. So I'm going to say sine of my angle. My angle here is theta. So sine of theta equals 4 over 10.
And you do the same to the -1 and all that good stuff, and cancel out to one side, and you just punch it.
Alright, so now we're going to do what we just did and take the inverse sine of both sides of the equation. Alright, so what we end up with then is theta equals the inverse sine of 4 over 10, and that we just put into the calculator.
And it's 23.57. Or 23.58.
23.58. So Theta is 23.58 degrees.
Why is it just like towards the end of your hair, it just starts being blonde?
Because, I mean, it got bleached over the summer. I mean, like, by the sun. You know, it always does every summer. So, like, this is, like, newer hair, so it's not as blonde.
Yeah, the educated.
I'm outside a lot.
Is it like a flex? It's no big. Oh my god.
It's not flex at all.
No, it does.
I'm outside, so the sun is.
Yeah, I'm not sorry.
Get like natural highlights.
You ain't outside. You ain't cool now.
Alright, do we feel like we can try a couple of these here, or do we want to do another one together?
One more.
One more? Okay. So, let's label our sides. So, with respect to theta, is 5 opposite, adjacent, or hypotenuse? Adjacent. How about the 9? Hypotenuse. So, what trig function? Cosine. Yeah. So, what will my setup be? Cosine of theta equals 5 over 9. Now what? Take the inverse cosine of both sides. So when I do that, this all cancels. I just get theta equals the inverse cosine of 5 over 9. So what do we get when we put that in the calculator?
Theta equals 56.25.
56.25 degrees. Feeling okay?
Oh, yeah.
All right. You guys go ahead and try number 3.
Fletcher, you feeling good?
Still a little,
No, you didn't.
little sick.
Nike. I can't believe you just said that. You're so gross. You're disgusting.
Here you go. Can you switch?
Sure. So what do we get for number 3 here? 67.38. Okay. We feel okay with that one? Alright, let's take a look at number 4 then. Okay. On this one, I'm given all 3 sides. What should I do here if I'm given all 3 sides?
All for all 3.
Solve for all 3? Well, I guess we could do that. So, we want to label all 3 sides, yeah. So with respect to theta, 9 would be opposite.
Adjacent 40.
Okay. So now if I have all 3, which trig function should I choose? Let's just do 2 and see what happens. Yeah, so we're trying to solve for theta.
All the sides have to add 180.
All the angles would have to add up to 180. Yeah.
So the bottom one is 90.
Right, we know this one's 90. So how should I solve for this angle here? What trig function should I use? Any of them, right? We have all three sides, so it doesn't matter which one I use. Which one do you want to try? All right, let's do sine. So if I use sine of theta will equal what? 9 over 41, and opposite over hypotenuse. So we take the inverse sine of both sides. And theta is the inverse sine of 9 over 41, so what do we get? 12.68. Okay, let's try solving for theta using one of the others, either cosine or tangent. Alright, so let's do cosine. Okay, if I say cosine of theta, what would cosine of theta be in this case? 40 over 41? So to solve, I would take the inverse cosine of both sides. So what's the inverse cosine of 40 over 41? 12.68. Take a wild guess at what we would get if we used tangent. 12.68, right? So we don't need to do it 3 times, right? No matter how we solve this, we're going to get 12.68. Okay, so if we're given for all 3 sides, I can choose any trig function to solve. Okay, we don't have to do all 3; we just have to do it once. So our answer here should be 12.68 degrees. Okay. Questions? Feel all right? All right, let's flip over to the back. Okay, and oh no, it's good on your paper. I don't know why it's not on mine. So here, we are just going to draw our own triangles. Just like in the last section, we're going to draw our own and then solve just like we've been doing. So remember, for all of these where we have to draw our own triangle, it says C is the right angle. So my triangle will be set up like this. Capital A, capital B, and capital C are the angles. Then the side opposite angle A is little a, the side opposite angle B is little b, and the side opposite angle C is little c. So I can draw my triangle now, given this information. So my goal here is to find angle A. That's my theta. Okay, if it says find the measure of angle A, that's where my variable is going to go. Okay, then it tells me that side A, so side A is opposite angle A, is 2 times the square root of 6, and side C, which would be the side opposite angle C, is 9. So, now, I'm just going to solve exactly like we've been doing. So I want to label the sides of my triangle. So with respect to my theta, 2 square root of 6 is opposite, and the 9 is hypotenuse. So what trig function? Sine. So I will say sine of theta equals 2 square root of 6 over 9. Now what? Take the inverse sine of both sides. And I can put this into the calculator now. What do we get? 42.98. Questions? Alright, then I want you guys to try the other two on here. Alright, on B here, I think this should be our setup. Right? Where my theta is in angle B, and I know side B is 3 and side C is 5. So I would say sine of theta equals 3 over 5. Take the inverse sine of both sides, and then I can put this into my calculator. What do I get? 36.87. You feel okay with this one? Are we? Looks like some people are still working on C, so I'll give you another minute here to finish up C, and then we'll talk about that one here. So what did we get for this one?
32.47.
32.47 degrees.
You would take off points and don't put the degrees on.
Probably not, but I mean, I do want you to put it. It is correct to show that this is degrees. Any questions at all on finding angles in right triangles?
It's gonna get harder.
Not really.
I feel like it'll.
Well, I mean, the next thing we're going to do is solve for all the missing pieces.
Oh my gosh. Yeah.
But, I mean, that's just, we'll just have to do a couple of trig setups for one triangle.
Oh, great. Oh, what?
All right.